In this video, we will solve a problem on evaluating limits. The question is evaluating limit as x tends to 0, 1 plus x under root minus 1 minus x under root upon x yields to, the options are 0, under root 2, 1 or cannot be determined. Okay, so we need to evaluate this limit as x tends to 0. Okay, if we simply put x is equal to 0 in this function, so in the denominator we will have 0 here, and numerator upon 0 will give us indeterminate number. Okay, so we will use L'Hopital's rule here. Okay, L'Hopital's rule to evaluate this very kind of limit. Okay, so simple, we have limit as x tends to 0. By L'Hopital's rule, what we do, we just simply take the first derivative or derivative of numerator and denominator separately. Okay, to get rid of this indeterminate form. Okay, so the derivative of this 1 plus x. Okay, so what is the derivative of 1 plus x? So 1 plus x can be written as this. Its derivative is 1 upon 2 1 plus x minus 1 upon 2, and derivative of x is 1. Okay, so the derivative of this function will come out to be 1 upon 2 1 plus x raised power minus 1 upon 2 minus the derivative of this 1 minus x. So we have here minus, here we have minus, and here we also have minus. Okay, simple thing. So its derivative will be simply again we have minus here again, so we have minus 1 upon 2. Okay, then we have 1 minus x raised power minus 1 upon 2 divided by derivative of x is 1. Okay, simple thing. What I have done here, I have just taken the first derivative of numerator and denominator with respect to x to get rid of this indeterminate form. Okay, so writing it further, that means limit as x tends to 0. This can be written here 1 upon 1 plus x under root. Okay, if I transpose it to the denominator, this 1 upon 2 negative sign will become positive. Now minus into minus is plus here, so plus we have 1 upon 2. Okay, transposing this to denominator, this is 1 minus x. Okay, whole divided by this one. Now when we evaluate it as x tends to 0, what will we get? We have 1 upon 1, the value of x is 0. Let's write it 0. Again we have under root 1 minus 0, taking the value of 0 here, and we have 1 here. So this is simply 1 upon 1 plus 0 is 1, so under root 1 is 1, and obviously we have 2 here that I forgot to write, so 2 here. So this will become 1 upon 2. Okay, this whole step becomes 1, plus we have 1 upon 2 divided by 1, which comes out to be 1. Obviously 1 upon 2 plus 1 upon 2 is 1, then we have 1, which comes out to be 1. Okay, so the limit as x tends to 0 of this function can be this, that is it equals to 1. We use L'Hopital's rule to get rid of this indeterminate form here. Okay, I hope I make myself clear. Thank you.